Hi guys, we are GCSE Revision and we're gonna go through trigonometry in 3D solids. So this is 3D space. It's right time to practice your skills not only in 2D but also in 3D. And particularly we consider pyramids as one probably hardest stuff and hardest object amongst 3D solids for students. Okay, so grab your pens, grab your notes, and we consider this problem that has several questions in a row. That's the good demonstrations of different aspects of trigonometry. Trust me, it will work for you guys on the exam one day. Okay, so let's get started. We have rectangular base pyramids. ABCD is a rectangular base, so it's a rectangle and it's horizontal. KM is the vertical perpendicular to the base, so that's why KM will arrange 90 degrees angle, let's say with the diagonal AC and both actually with both diagonals BD as well, because it's perpendicular to the rectangle plane where it lays on. Okay, so first of all we need to calculate KM. Let's try to do this. So what we're going to have KMC in 3D, actually you need to go to 2D case, and I'll just show you how it can be done. So we can drop triangle KMC is right there, so this is triangle KMC, and I recommend to draw separately if you get confused on 3D. So we just simply take out triangle KCM, it's right angle. So what we have 10 centimeters here. We don't know the bottom base MC, so let's mark as X. And finally, we need to find Km, which is, let's set it as Y. So Km is simply Y. Okay, let's set up Pythagoras here. Y squared and X squared will give you 100. X squared and Y squared will give you 100. All right, so that's good. And what we need to do, we need to find X first. So find X and then find Y, okay? So how to find X? X is right there. However, we know that if we double X, we'll have 2X stays for diagonal AC, because you know that diagonals in the rectangle, they splitting on two equal parts with a common point M, okay? With a common point M. So that's why two parts are identical, and we can say that if we consider triangle ACD, now let's draw up another triangle. So, however, I'm not going to draw, just watch right there. So if I shade this triangle, you'll see that it lays on the bottom, and this triangle ACD. Okay, so let's have a go. Triangle A, C, and D, from where we can figure out that 2x is hypotenuse, so 2x squared will be equal to 8 squared and 5 squared together. 8 squared and 5 squared together. So using calculator, you can figure out the x value. So first of all, 2x from there, and it's square root of, I'm pretty sure that we won't have any whole number for that, so that's why it's 64 plus 25 square root. And what I've got 9.4, let's say 43 centimeters, and now we can figure out the value x by dividing everything by 2. So 4.72, so 4.72 centimeters that we've got for x. Now we can simply figure out y value, and it simply can done. I just squeeze a little bit, okay? So we can figure out value y from there using that formula, Pythagoras, as square root of 100, not squared anymore, minus x squared, so minus this figure 4.72, which is squared. Okay, so that's the final value for y, and let's calculate this. So we have 100 minus 4.72, which is also squared. Okay, what I arrived to the answer y equals 8.82, so 8.82 centimeters. And that stays for km, so this is km, and I circle this answer because that's the first answer for the first question A. So this is A, okay? All right, so we've done A, and let's have a go to B. You need to find the volume of the pyramids. All right, so let's just remember the volume formula. You remember for upright bodies like prisms, cylinders, pyramids. This is the general formula, like area of the base times height. So this is the general formula. However, for the bodies like pyramids and cones, you simply taken the adjustment factor as 1/3. This is the good way how you can memorize the formula for all set of figures. And actually, if you watch my video dedicated to mensurations, volumes of 3D solids, you can get a shortcut how to get universal approach to in calculating the volumes. Definitely you will need this later study on your first education, and because you're not supposed to use any formula there. So mostly you'll need to know that and save it in your head. So, okay, about the volume, do we need, yes, we need height. We recently find this is km. So if we rewrite this formula for volume, we'll get simply 1/3. Okay, I just a little zoom up. Okay, so in B, yes, we need to use the formula for the base. It's rectangle, so it's 8/5. So it's 8 times 5 times 1/3. And also we need to times the height that we recently calculated. This is y value. It's 8.82 centimeters. All right, so let's calculate this in one single action. So 40 times 8.82 and over 3. I've got 117.6 centimeters cube. So that's the volume. So finally we've got the volume using that formula, and the volume is that figure. Okay, so hope you got the same. Here we go. So that's the answer for B. So that's B. So B, okay, that's B, that was A. And now we move next. Find the angle AKC. AKC. Okay, so to find this angle, I want to move to another slide. So just because I really restricted to the area of the workspace. So find the angle AKC. So I just mark this angle on the diagram, and this is the angle between AK and KC. So it's inside. However, for this reason, I can consider what? If I take triangle KMC, I'll definitely get the half of that angle. So if I do the same, actually, I'll get this angle, right? Let's have a look. So this is what we have. MKC, so M, K, and C, and we have half of that angle. So this angle is simply, say, alpha over 2, while the total angle that we need to find is alpha. Okay, so this right angle, we know 10. We found M at MC, that was X, you remember. Let's go back to the slide. So it was X, 4.72 is right there. Okay, so 4.72, and this 4.72, and we can easily use trigonometric ratio. So 10 is hypotenuse, 4.72 is the opposite leg to the angle, So we can calculate alpha over 2 is simply for writing for formula for the sine alpha over 2 is 472 over 10. So actually let's calculate. So sine alpha over 2 is equal to 4.72 over 10k. We've got 0472, from where we can find alpha over 2 by taking inverse sine minus 1 of the figure 0.472. Okay, so press the calculator. Sine of 0472. And we got alpha over 2 as 28.16 degrees, so just 28 degrees. And if we times 2 the result, we'll get alpha itself. So we've got around 56 degrees. I would write better for alpha. So alpha finally is double the angle 28, so it's 56 degrees. All right, so hope you understand why I use the half of the angle, because km is the height in the isosceles triangle. So this triangle, if you consider AKC, is an isosceles because each diagonal the same in the pyramid. So that's why km is bisector of the angle as well. So that's the reason. Okay, that was angle alpha in total. Okay, and finally, what we need to find? We need to find the angle between the height in the triangle KCD. So KCD is that triangle. Okay, so what I can do, I can simply KCD. Yeah, so if I say that I consider only half of the triangle KC, and let's say we put the height down. Okay, so let's say this is going to be height from there. We just put it down right here. So this is the height. It touched the segment CD in some point, let's say point L. Okay, so point L, and this is the height in this triangle. So we know that we formed a triangle made of height, hypotenuse 10 centimeters, and the bottom part, which is half of CD. CD is 5, so it's half. So that part is equal to that part, because height in the isosceles triangle, one more time, this is isosceles triangle, so this part, this side KC is equal to that side, and that's why height is going to be a bisector of the middle of the segment CD. So one more time, LCK, height is bisector, so that's why for LC it's half of 5 stays, so 2.5. So we've got 10, we've got height, and we've got 2.5 as length and hypotenuse. What we can do, we can simply use Pythagoras. So h is simply 100 minus 2.5 squared. Okay, so Pythagoras here. Let's calculate height first. Oh, wait, what were you doing? Actually, we don't need height, sorry. Yeah, I was thinking that we're looking for their height. We don't need height. We just simply need to calculate the angle between the height in the triangle and the base. Between height of the triangle, yes. Oh, yes, height in the base. Anyway, yes, we need to look for it. So first, we're looking for height, as I wrote, square root of 100 minus 2.5 squared. Let's calculate it quick. So we're taking square root of 100 minus 2.5 squared. And we've got for height 9.68. And let's consider the angle itself. So which angle we are considering? So that's, we just simply use triangle to apply Pythagoras and we calculate the height. And now we need to use the height and the base BCDA. So the angle that it will arrange with the base is going to be simply here. If you put projection like this, from this height, you'll get the shadow M, let's say ML. So the shadow ML. And it means this shadow will have the half of 8, so you know it's 4. But actually you can use KM as well. So it doesn't matter which you're going to use. We know height. We know, let's say this is the half, right? It's half of AD, it's 4. So from where we can figure out simply the angle, which is height arranged with the base. So one more time, if I draw now this triangle KLM, you'll see that it looks like, so here is KLM, triangle KLM, M here, L here, and K here. So we need to have this angle, say angle theta. This is the height that we recently calculated. It's 968. And we also can use that for ML. So from where we can figure out, let's say, cosine theta. So cos theta is the ratio 4 to 9.68, from where we can find theta as cos minus 1. So let's take the cos minus 1 from the fraction 4 over 9.68. I will get 65.59 or 0.6 if you want degrees. So that was the final angle and that was the answer for D. Okay, so we've got all the answers. That was for the previous one. A and B we did before, so on the previous page. So we can go back and just have a look at the answers here. So make a print screen if you like to fix the answers and try to compare it with your own. So this is A, this is B, and also C alpha is 56, and finally theta is, and finally theta is 65.6. Okay, you see that in many cases we actually drop triangles that occurs in 3D. So we just take it away and consider it separately. So that's really helpful and useful. So try to do the same, and this is the idea how you can work it out. All right, so I hope you like that. It was pretty complicated problem. I can say that it's hard for high math level. So make sure you understand every single part, because if you know every single, like if you're able to answer on every single question here, you can solve the combined problem that you might find on your exams. 3D trigonometry, and that's how it works. Hope you like that. If you're new here, smash the bell button please. So subscribe, like and share this video to anyone who's interested in math, and not only in math, so you can find probably soon later more a bit later on more stuff for other subjects. So I consider particularly physics as well. So, but right now I need to finalize my GCSEs. Okay, thank you guys, and see you later.